Hi everyone! Today we are going to be looking at perimeter, and we are going to be checking out perimeter of composite shapes or composite figures. So first thing we need to know is, what is a composite figure? Well, a composite figure is just like a composite rock. So a composite rock is made up of all different types of little rocks put together. A composite figure is the same thing, except it's a shape. So a composite figure is a figure or a shape that's made up of many different types of shapes. So it can be made up of, it's a shape made up of other shapes. Like, for example, triangles, squares, rectangles, semicircles, other two-dimensional parallelograms. So triangles, squares, rectangles, semicircles, etc. So many other different types of shapes, etc. So composite figure is a figure that is made up of more than one shape. So it's made up of other shapes. All right, so let's look at an example of a composite figure so you can see just what I mean. So let's say that I have a figure that looks like this. Okay, I have this shape here. Well, this shape is a composite figure. It's composite because if I draw a line right here, it is made up of a triangle and a square. So it's made up of a square and a triangle. And that is how I get the whole entire figure. If I had a figure that looked like this, okay, this is also a composite figure because if I cut it here, I have a rectangle and I have a semicircle. So it's made up of two shapes. Sometimes we have things that are made up of more than two shapes. Those are also composite figures. So the way that we find the perimeter of a shape is by looking at the outside. We're not so much worried about the inside of a shape, okay? So on a composite figure, the only thing that we're worried about is looking at the distance around the whole shape. So when we're looking for perimeter of those shapes, of a composite shape, we are adding the distance around the whole shape, okay? Not the inside. So we're thinking about only the parts that we walk on. Okay, so that would be the perimeter. So around the shape. So around the outside of the shape. Okay, not the inside. So let's go ahead and start looking at some examples for how to solve the distance around those shapes. So we have a figure that looks like this. Let me draw it out for you. And this figure that we have example A. Okay, so we're looking at example A. Example A happens to look like this, almost like a baseball diamond. Okay, the outfield. There we go. All right, so this figure here is made up of 10 feet here, and it's also made up of 8 feet and 6 feet. And we want to know what is the perimeter. So our job first is going to be to look at the sides that we have. So I'm going to use some markers to help us. All right, so first we see 2 different triangles. One triangle. So let's look at the parts that we walk on the triangle. Where do we walk on this triangle on the outside of the shape? Well, on the triangle, we're just going to walk here and here. So I'm just going to add 8 feet and 6 feet. Okay, that's where I walk. Now, I also have a semicircle. Okay, and on my semicircle, let's switch to a different color. On my semicircle, I am only walking on the perimeter that is here. So just the curve. So let's look at my semicircle. I might need to look back if I don't remember, but semicircle, to find the diameter of a whole circle, the circumference of a whole circle. We're gonna look back. That's area. We just want the circumference. How do we find the perimeter of a circle? Circumference. So circumference is pi times the diameter. So pi times the diameter. And then we need to cut it in half because it's a semicircle. So I'm going to use 3.14 and my diameter is 10. So times 10. And then I have to chop the whole thing in half. So to find this one and this one, I added 8 and 6. So far 8 plus 6 is 14 feet. So on the green part, I've walked 14 feet. And then on the orange part, I have walked 15.7. Let me double check that just to make sure. So we've got our calculator here, and we are going to go 3.14 times 10, and that gives us 31.4. We're going to divide that in half, and we get 15.7. Now, in a normal semicircle, the reason why we would then add on the diameter is because we would walk the diameter. But in this shape, we are not walking on the diameter. So in this shape, all we're doing is just walking the green part plus the orange part. So we're going to add the 14 and the 17, and that gives us a grand total of 29.7 feet. So if I add 14 plus 15.7, I get a total of 29.7 feet. So that is the circumference, or the perimeter, not circumference, that's the perimeter of the shape. So I've walked along the outside edge of the whole shape. I'm not concerned about the inside because I'm not walking there. I'm just walking around the edge. All right, go ahead and finish writing that down. And now we're going to look at another shape. So I'm going to try to squeeze it in right here. Hopefully I can. Okay, this next shape that we have is actually really interesting. So this composite shape is made up of what looks to be a square. However, the part that we're walking on is actually the semicircles on the outside. Okay, but we need these diameters here in order to walk. So it says from here to here is 2 inches. And from here to here is 2 inches. Here to here is 2 inches. And same thing, 2 inches. All right, so what we're looking at is a walk around the outside of our shape. Okay, so let's highlight or color the part that we are walking on. So we are going to walk here, and we're going to walk here, and here, and here. It kind of just looks like a bunch of curves, right? So the only parts we're worried about is the curve. However, we can't find the area of the curve, the perimeter of the curve, unless we use the square in the middle, which is 2 inches. So this acts as the diameter. So let's talk about circumference. So we know that circumference equals pi times the diameter cut in half. Okay, and so what I'm going to do now is I am going to do 3.14 times 2 inches, and then I'm going to divide that by 2. So 3.14 times 2 gives us 6.28. And then I need to divide that by 2. I'm going to guess it's 3.14 divided by 2. Oh, look at that, 3.14 inches. So every hop around this thing is 3.14. And I have 4 that are identical. So I'm just going to take 3.14 and I'm going to multiply that by 4. So this is 3.14, this one's 3.14, this one is, and this one. So the perimeter is plus each of those, or I'm just going to multiply it by 4 because I can. This means the exact same thing. And I get 12.56 inches. So jumping around or walking around this, it kind of looks like a fountain. I bet you could have like a fancy fountain in the middle there, and you would get about 12.56 inches. Okay, we are going to do one more example, and then I will give you a try it. Gotta keep my eye on your timer down there just to make sure that you have enough time to also do your practice work. That looks identical. All right, let's do this one. This one looks interesting to me. All right, so on this example, we have let's go example C. We have a shape that looks like this, okay? And it has an even dashed line going across, and it says that the whole thing from here to here is 12 feet, and it says that this is 3 feet here, and it says that these are 3 feet. So our job then is to figure out this perimeter. So first of all, we can look for the area around the outside of the shape. So the part that we want to worry about is the curve here, 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 another curve, and here. We don't really care about the dotted line. We only need the dotted line in order to find the curves. So first of all, let's look and see all of the feet that we have, okay? So we have 3 feet, 3 feet, 3 feet, 3 feet, 3 feet, 3 feet, and 3 feet. So 1, 2, 3, 4, 5, 6. So we have 6 times 3 feet. That's going to give us a total of 18 feet. That represents all of the rectangle parts. Okay, now we need to worry about the 2 semicircles. So for the semicircles, we know this whole thing from here to here was 12 feet. But then it took out 3 feet here and 3 feet here, which means that what's left over is going to be 6 feet. So we're going to use 6 feet, and we're going to use, for our diameter, we're going to use 3.14 times 6 feet, and then we're going to cut it in half because we're only walking on the outside of this circle. So when I multiply 3.14 times 6, that gives me 18.84. And I now need to divide that by 2. So I'm going to divide that by 2, divide by 2, and I get 9.42 feet. Okay, so I have my semicircles plus my rectangle. I need to add both of those parts up. 18 plus 9.42. So 18 plus 9.42, because I walk around that whole entire thing. And I get a total of 27.42 feet. So that's how far I walk. All right, it is your turn now to do a try it. Let's give you a try it that is going to work out well for you to do. Oh, goodness. Let's see. Oh, okay, let's do this one. So here is your try it. Try it number 1 and only number 1 is a square with a dome top. And it says 5, meters and 5 meters. So go ahead and hit pause. It looks like a loaf of bread. Okay, go ahead and hit pause right now so you can try to solve this for yourself. And then when you are ready, come on back and check your work. All right, so the first thing we want to look at is the perimeter. This is 5 plus 5 plus 5. So the perimeter of the square that we're walking on, only the parts we are walking, is 5 plus 5 plus 5, which equals 15 meters. Okay, then we also have the top of this, which is this dome part here. And I'm going to use this square part of 5. So the dome or the semicircle is going to be 3.14 times 5. And 3.14 times 5 gives me 15.7. So I get 15.7, but I have to divide that in half. So now I divide by 2, and that gives me 7.85 meters. So I have 2 answers now. I need to now add the blue and the green parts together. So 15 plus 7.85. And that gives me a grand total of 22.85 meters. All right. How did you do on this one? 22.85 meters is the outside of that shape. Go ahead and rate your, answer your essential question. How do we find the perimeter of composite shapes? And then put your level of understanding out to the side. When you are finished, you may come on back to the Google Meet and ask for help if you need it, or you can go on and do your practice work. As always, I appreciate all of your hard work and effort, and make it a great day.